Hi and good evening to Mrs. Fu and all our friends. Today we are going to present about probability. Subjective probability. The probability assigned to an event based on subjective judgments, experience, information and belief, assigned arbitrarily. It is usually influenced by the biases, preferences and experience of the person assigning the probability. For example, the probability that Farah, who is taking statistics, will earn an A in this course. Solution: neither the classical probability rule nor the relative frequency concept of probability can be applied to calculate probabilities for this example. This example belongs to experiments that have neither equally likely outcomes nor the potential of being repeated. Farah will take the test only once, and based on that she will either earn A or not. The two events, she will earn an A and she will not earn an A, are not equally likely. The probability assigned to an event in this case is called subjective probability. Farah may assign a high probability to the event that she will earn an A, whereas her lecturer may assign a low probability to the same event. Next, continuing rule. A counting rule. If an experiment consists of 3 steps and if the if the first step can result in R outcomes, the second step is S outcome, and the third step in then the total for the experiment equals to R multiplied by S and multiplied by T. Example, suppose we toss a coin 3 times. This experiment has 3 steps. The first toss, the second toss, and the third toss. Each step has 2 outcomes, a head and a tail. Thus, total outcomes of 3 tosses of a coin is equal to 2 times 2 times 2 is equal to 8. The 8 outcomes for this experiment are head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, and tail, tail, tail. Marginal probability. The probability of a single event without consideration of any other event. Marginal probability is also called simple probability. For example, suppose all 100 of a company were asked whether they are in favor of or against paying high salaries to the CEOs of telecom company. A two-way classification of the response of these 100 employees are gender, uh, in favor, against, and total. So the male will be 15 and against will be 45 and equals to 60. The female is 4, against is 36 and total is 40. So the total in favor is 19, against is 81 and total is 100. So solution for the 4 marginal probabilities are P male is equal to 60 over 100 is equal to 0.60. P female is equal to 40 over 100 is equal to 0.40. P in favor is equal to 19 over 100 is equal to 0.19. P against is equal to 81 over 100 is equal to 0.81. Conditional probability. The probability that an event will occur given that another event has already occurred. If A and B are 2 events, then the conditional probability of A given is written as P A B is equal to P in bracket A Uh,
Intersection.
Intersection B over PB and read as the probability of A given that B has already occurred. Example, compute the conditional probability B in favor male for the data on 100 employees. The conditional solution, the conditional probability that a randomly selected employee is in favor given that this employee is a male are P in favor male number of male who in favor over total number of male is equal to 15 over 100, which is 0.15. This is a tree which consists of event already occurred. Male is equal to 60 over 100 and female is equal to 40 over 100. And the favors for male is 15 over 60 and against for male is 45 over 60. For the female, the favors are for 4 over 40 and the against for female are 36 over 40, which we are to find the probability of this event. Mutually exclusive events are events that cannot occur together. If two or more events are mutually exclusive, then at most one of them will occur if every time we repeat the experiment. For example, consider tossing a twice. This experiment has four outcomes, which is head, head, tail, and tail. These outcomes are mutually exclusive because one and only one of them will occur when we toss this coin twice. For example, consider the following events for one of the roll of a die. A is equal to an even number is observed, so equals to 2, 4 and 6. B, an odd number is observed, so is equal to 1, 3 and 5. C, a number less than 5 is observed is equal to 1, 2 and 3 and 4. Are events A and B mutually exclusive? Are events A and C mutually exclusive?
And the solution for mutually exclusive events A and B, for one roll of a die, only one of the two events A and B can happen. Hence, these are two mutually exclusive events. And mutually non-exclusive events A and C, if we roll a die and obtain a 2 spot or a 4 spot, then A and C happen at the same time. Hence, events A and C are not mutually exclusive. Independent and dependent events. Independent events are two events are said to be independent if the occurrence of one does not affect the probability of the occurrence of the other. In other words, A and B are independent events if either probability A given B is equals to probability A or probability B given A is probability B. And dependent events, if the occurrence of one event affects the probability of the occurrence of the other event, then the two events are said to be dependent events. In probability notation, the two events are dependent if either probability A given B is not equal to probability A or probability B given A is not equals to probability B. An example, refer to information on 100 employees from preceding example. Are events female F and in favor A independent, the solution is events F, which is female, and A, which is agree, will be independent if probability F equals to probability F given A. Otherwise, they will be dependent. Using the information given, we compute the following two probabilities. Probability F is equal to 40 over 100, which is 0.4, and probability F given A is 4 over 19, 0.2105, which is probability F is 4 over 10, and F given A is 4 over 19, which is not similar. So both events of F and F given A are not independent, so they are dependent. Because these two probabilities are not equal, the two events are dependent. In this example, the dependence of A and F can also be proved by showing that the probability A and probability A given F are not equal. There are two important observations. We can make two important observations about mutually exclusive, independent and dependent events. Two events are either mutually exclusive or independent. A, mutually exclusive events are always dependent when the intersection probability is equal to 0, and B, the independent events are never mutually exclusive where the intersection between both events is equal to the multiplication separately. The note is the exception to this rule occurs when at least one of two events has zero probability. And two, dependent events may or may not be mutually exclusive. And complementary events, the complement of event A denoted by A bar or A complement is the event that includes all the outcomes for an experiment that are not in A. Therefore, the probability A plus with probability A bar is equal to 1. From this equation, we can deduce that probability A bar is equals to 1 minus probability A. And the following is Venn diagram of two complementary events, which is outside the A is A bar or A complementary. An example, in a group of 2,000 taxpayers, 400 have been audited by the LHDN at least once. If one taxpayer is randomly selected in this group, what are the two complementary events for this experiment, and what are their probabilities? The solutions are the two complementary events for this experiment are A, the selected taxpayer has been audited by the LHDN at least once, and A bar is the selected taxpayer has never been audited by the LHDN. So the probability A is 400 over 2000, which is 0.2. So as we can observe, the sum of this probability is 1. So 1 minus 0.2, we can get the probability of A complement, which is 0.8. An intersection of events and the multiplication rule. Intersection of events. Let A and B, two events defined in a sample place. The intersection of A and B represents the collection of all outcomes that are common to both A and B and is denoted by A and B or A intersect B or AB. And this is the Venn diagram of intersection of events A and B. Multiplication rule. The probability that events A and B happen together is called the joint probability of A and B is written as P as probability in bracket A and B. Joint probability. The probability of the intersection of two events is called their joint probability or intersection probability and can write as probability A and B or probability A intersect B or probability in bracket A and B. A times B. And multiplication rule, the probability of the intersection of two events A and B is P probability A times with probability B given A.
And the following table gives the classification of all employees of a company by gender and college degree. College graduates for male is 7 and not a college graduate also for male is 20. So in total we have 27 males and for females we have 13. 4 of college graduates and 9 of not a college graduate. So the total college graduates that we have is 11 and the total non-college graduates we have is 29. So in total we have 40 of them. If one of these employees is selected at random for membership on the Employment Management Committee, what is the probability that this employee is a female and a college graduate? Which means P in bracket F times with P G given F. Notice that there are 13 females among 40 employees. Hence, the probability selected is PF equals to 13 over 40. To calculate the probability G given F, we know that F has already occurred. Consequently, the employee selected is one of 13 females. In the table, there are 4 college graduates among 13 female employees. Hence, the conditional probability of G given F is 4 over 13. The joint probability of F and G is PF and G equals to PF times by G given F equals to 13 over 40 times by 4 over 13 will obtain 0.10. Thus, the probability is 0.10 that a randomly selected employee is a female and a college graduate. The probability in this example can also be calculated without using multiplication rule. For example, P, F and G equals to 4 over 40, which is 0.10 as well. Multiplication rule for independent events. The probability of the intersection of two independent events A and B is PA and B equals to PA times PB. This is because when events A and B are independent, probability of A equals to A given B and probability of B given A. Substituting this into the formula, for joint probability of A and B, we obtain A and B, probability of A times by probability of B.